Yo, can you just leave it on the tower for a moment? Thank you so much. Alright, so today our learning target says I can write the inverse, converse, and contrapositives of conditionals. So that's what you're going to be able to do by the end of the class period. Now, first, let's talk about what a conditional statement is. So that's the first thing that we're going to open. Is everybody ready? Open this flappy. So, they are written in, and I don't know why it printed like this. I just don't know what happened with this foldable, guys. Super sorry. They are written in if, then form. So that's like that activity with the triangle and the rectangle that we did. If you had a triangle, then you do this. And they can be true, or they can be false. Take a point. So they have two parts which you're going to have to identify for me. They have the hypothesis and the conclusion. Now, you have taken science forever. So you can tell me what a hypothesis is. Look at y'all go. Take a point, children. So that's usually the beginning, right? Yes, no, maybe so? And then what's the conclusion? The end of it, the answer. So, you remember when we had the P and the Q for the truth tables? The hypothesis is the P, the conclusion is the Q, and when you write these, if and then are not included. So, when you write if and then are not included. So what's the hypothesis of this conditional over here? What is the hypothesis? It is raining. If and then are not included. So the hypothesis is it is raining. What's the conclusion? Dun, da, da, da. That's all you have to do. Whoa. Right? Crazy. Throwing some wild stuff at y'all. Now, does anybody have any questions? Are we ready to talk about the negation? What does the word negation mean? Opposite. We've talked about that, right? Take a point if you said opposite. So let's open the negation flappy. After I make it pretty, because I just can't stand it that it doesn't have any kind of fun font or anything because it didn't print right. Stupid computers. All right, a negation is the opposite of the original statement. So our original statement, our original hypothesis is it is raining. What is the negation of that? It is not raining. Take a point. And that's all you have to do for negation. Isn't it crazy? What if I said it is hot outside? What's the negation? It is hot in here. You were annoying. There we go. Alright, so we're ready to talk about converse and inverse? So this is where it gets fun. This is where we start switching stuff around. It's craziness. This is part of what your project's going to be. Get super excited. Converse. Let's open this bad boy up after I decorate, because I can't. It was so pretty, guys. I made it so pretty. Alright, the converse is formed by reversing the hypothesis and the conclusion. So you start with your conditional. Our conditional was, if it is raining, then the ground is wet. And we said, it is raining was our hypothesis, and the conclusion is the ground is wet. Now, for the converse, we flip everything around.
And the ground is wet if it is raining.
No. Flip just the hypothesis and the conclusion. Leave if and then in the same place.
If the ground is wet.
Ainsley's telling us.
If the ground is wet, then it is raining.
Take a point. If the ground is wet, then it is raining. So these guys stay in the same place because it told us that we were reversing the hypothesis and the conclusion. And what we learned about the conditional is that if and then are not included in the hypothesis and conclusion. So you leave if and then in the same spot. You flip around the other fun stuff. Does everybody understand? All right, what would the converse of if it is cold outside, then it is December? Fantastic. Is that always a true statement? No, because we live in Alabama and it's 4,752 degrees here. Any questions on the converse? What about if it is September, then it is fall? All you have to do is flip them around. If and then stay in the same place. Now let's talk about inverse. What do you think the inverse is? What does inverse mean when we're talking about fractions?
Switching them around.
Switching them around, right? What do we mean when we talk about fractions when it's the opposite inverse?
Same.
Does the sign change? The sign changes, yeah. So with inverse is the negation. So inverse is formed by adding not to the hypothesis and the conclusion. We add not to both of them, to the hypothesis and the conclusion. So to both of them, it looks like a fat little dinosaur, to both of them.
So it'd be like if it's not raining, then the ground is not wet.
Yes. Take a point. So the inverse of this conditional, everything stays in the same place. We don't switch them around. We just add the word not. So we would say, if it is not raining, then what? The ground is not wet. Is that always a true statement? Blair, learn how to spell the word is. Pardon? It could just be the dew in the morning outside.
No. Yeah.
Yes, it is, pumpkin. Yes.
You
You can shorten it to say is. Alright, if it is not raining, then the ground is not wet. Does anybody have any questions about converse and inverse? Are we sure?
Why is the and?
I'm sorry, I need to open it up because you were talking and not writing stuff down. Oh no, it's open.
No, it's cool. I don't need that. You close that.
Alright, let's move on. The last one that we're going to talk about that is important is called the contrapositive. Now, these three have a special name, and we're going to write that on the outside of our flappies in a minute. But the contrapositive, one, it's a fun word to say. Say it, you'll have fun. Look at you go. This pen is dying. Alright, so the contrapositive is where you reverse it and you add not to it. So we're doing all kinds of fancy things for this one. So the contrapositive is formed by reversing the hypothesis and the conclusion. Oh, I'm sorry, I didn't move my paper over enough. And adding not. So we flip it and we add not. Now, who can raise their hand, not scream at me, and tell me what the contrapositive of this conditional would be? Jarvis.
If it is not raining, if the ground is not wet, then the ground is not. If it is not, the ground is not wet, then it's not.
Yes, take a point. All right. So if the ground is not wet, then it is not raining. Dun, 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 dun. Now, these three things have a special name. The converse, inverse, and contrapositive are all called related conditionals. So write that somewhere on the outside of one of your flappies. They are called related conditionals. I'm going to put it right here. I'm going to write related conditionals. And I'm going to draw an arrow. What is a conditional? Open the flappy that says conditional and tell me what a conditional is. What?
If, then.
It's an if-then statement, right? A conditional is an if-then statement and it can be true or false. Okay, what is the negation? Alright, what's the converse? Reversing. Alright, what's the inverse? Does the inverse flip or does it stay the same? Alright, what about the contrapositive? You reverse and add not. Fantastic. Now, the last one that we need to talk about is our equivalent statements. So when you flip stuff around and when you change things, they are still equivalent or equal. Isn't that what the word equivalent means?
Yes.
Okay, so we have statements. I don't know what just happened to my star. We're going to pretend like it doesn't look like that. So the original conditional statement and the contrapositive are equivalent statements. The converse and the inverse are also equivalent. Equivalent statements are two statements that have the same truth value. That means that they are both true or they are both false. Dun, 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 dun. Isn't it magic? You feel like what? Yeah. We write and draw a lot in geometry. Ready to try some examples? Alright, let's go to 12B. Which had which example number on it? What example number is on 12B? Thank you, Grant. Example 1. Take a point, Grant. Why do you have your phone out? No. Put it away. It shouldn't even be on your desk. It's red day. Away. Not in your lap. Away. Alright, this is 12B, example 1. It says identify the remix. Hypothesis and conclusion of the following statements. Are you guys ready? Can we all still see if I zoom out that much, or do I need to zoom back in? Darmstrong, can you see back there? Y'all are the ones furthest away. Do I need to zoom in any? All right, so hypothesis and the conclusion. Remember, your hypothesis is P. Your conclusion is Q. All right. Who can tell me what the hypothesis is of A?
If a polygon has
Does the hypothesis have if in it?
No.
No, we don't write that. Remember, we wrote that on conditional statement. Open it up. When you write if and then are not included. So, what is our hypothesis?
The polygon has 6 sides.
Take a point. So, that's our P. What is our conclusion? It is a hexagon. We don't include if and then. Any questions? Okay, let's look at B. Tamika will advance to the next level of play if she completes the maze in her computer game. So what is the hypothesis here?
Tamika will advance to the next level.
She completes the maze.
She completes the maze. She has to complete the maze before she goes to the next level. So our P is she completes the maze. And if she completes the maze, what happens?
she goes to the next level of play.
She will advance to the next level. All right, please do C without me. Are we ready? Does anybody need another minute? Okay, no rush. So do C without me. If you need to talk to your group, talk to your group. That's why we're in groups. You guys got it. Y'all with me? You on the same page? Does anybody have their signed release forms that you were supposed to bring to me on Friday? Yay!
So like,
All right, what is our hypothesis?
you are a baby.
I don't want to be a baby.
And what is the
You will
conclusion?
cry.
Is that always a true statement?
Yes.
Can you cry if you're not a baby?
Art doesn't count.
All right. Now, let's look at example 2. Hey, thank you so much.
You're welcome so very much.
I need your name on it. That doesn't help me if your name isn't on it.
I don't have the name.
Thank you. All right, example 2. The directions say identify the hypothesis Identify the hypothesis and the conclusion. Then write it in if-then form. Okay.
Well, all right.
If you measure the distance, then it is positive. So which one of those is our hypothesis? This one is P. All right. And then positive is Q. Okay. So if you measure the distance, then it is positive. Do we agree with that? Is that always a true statement? Yes, distance can never be negative, y'all. We cannot ever have negative distance. That's not how anything works. Not even mutter, 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 mutter. Exactly, because I'm still going the same distance, right? Take a point.
I want to argue, but I don't want to. I need to.
Why do you want to argue? That's not, okay. There are some universal truths.
Alright.
There are some universal truths, and distance being positive is a universal truth.
Alright, let's say you're in a straight line race. Alright. The distance, you got to go to the end, the road. You feel me? Alright. If you put your car in reverse, the distance you are now going in reverse. Alright.
That's not negative distance. That's not how anything works.
You can't go negative miles with your car.
You can't go, you can't go negative miles.
No, it's not. You go to
Yeah,
take
when they'll
distance
listen.
is positive.
Please don't roll your eyes at me either. Let's just let that go. Let's be Elsa. Either way.
It's okay.
Alright, so let's look at B, since I don't know what. Don't know. Alright, so a polygon with 8 sides is an octagon. What do you think is our hypothesis? Guys, I just want you to tell me the hypothesis. No, y'all, just the hypothesis. A polygon with 8 is, baby. Hypothesis and conclusion doesn't have if in it. So this is our P. Octagon is our Q. So if a polygon, what? Has 8 sides, then it is an octagon. Now, do you see how from the first statement to the conditional, we change a few of our words? It's red day, coach. All right, do you see how we've changed a few of our words from our statement to our conditional?
Yes.
So you can do that. You can change some of the words. Now, please do C without me. Talk to your group, figure out what C should be without me. We'll walk around and check. All right, somebody from Bo Battens, tell me what your conditional statement is that you created. That y'all said. Just in case you didn't know what your table name was. Somebody from your table.
If an angle has 45 degrees.
If an angle is 45 degrees, okay, love it. Then it is, can I write an acute angle? Awesome, take a point. Do we agree or disagree?
Agree.
So what was the hypothesis?
Angle that measures 45 degrees.
And what was the conclusion?
Angle.
Fantastic. All right, example 3. Example 3. Determine the truth value of the conditional statements. If true, explain your reasoning. If false, give a counterexample. All right, so if last month was February, then this month is March. Why?
Because
Are you sure? Okay.
I'm like 90% sure.
All right, if yesterday was Tuesday, then today is Monday.
It's true.
No.
False.
If yesterday was Tuesday, then today is Monday. Is that true or false?
It scared me how many people said that was true.
Me and you both, babe. All right, so that's false, but we have to give a counterexample. So what's a counterexample?
Monday comes before Tuesday.
Monday comes, okay, so Monday comes before Tuesday, yes, but this tells us if yesterday was Tuesday.
If yesterday was Monday, then today is Tuesday.
Okay. Take a point, all of y'all, that answered. Not those of you that said false. I mean, that said true. That said not those of you that said true. All right, so if yesterday was Monday, then today is Tuesday. So what if I use if yesterday was Tuesday, then what does today have to be? Okay. Stop it. So if P is true, then today is what? If P is true, so this is our P, right? If yesterday was Tuesday, if that's true, what does today have to be?
Wednesday.
Wednesday. Thank you. I was very confused as to why people were so confused on what the day was, so I was running. All right, tell me if example 2C is a true statement. Example 2C.
Oh, it is.
No.
It is.
Yes, it is true.
Example 2C.
It's true. Oh. Yes.
It's true.
It is a true statement?
Yes.
Why?
Because it's less
Because it's less than 90 degrees.
All right, what about B? Is that a true statement?
Yes.
Okay, we're not arguing A again. What about... All right, so we've already said all of those are true. Fantastic. Now, I'm going to... It's not. Your homework for tonight is to do example 4 on page 12C. Now, I'm going to pass out your logic project handout, and in the top drawer of your tower is your study guide if you want to go ahead and get that. In the top drawer of your tower is study guide. Now, what happens on Thursday? No. Test. Unit 2 test. What happens on Friday?
Test and project
Test and project due. What's the test on Friday?
perfect square.
Perfect squares. Alright, what is the perfect square? What are the first 4 perfect squares?
1, 4.
1, 4, 9,
1, 4, 9,
1, 4, 9, 16. What are the next 4?
16,
25,
25,
36, 49,
36, 49, 64.
Alright, how many of you need the note card back on the board so you can fill it out? Alright.
How many likes would it take you to send my 50 pop?
We're gonna make up enough.
Actually, all of it.